Hello guys, welcome to Ramta Solution. Welcome to your grade 10 probability. Today on the 8th lesson, we are looking at Venn diagrams. And by the way, Venn diagrams are the most, in fact, they're the favorite topics in mathematics for United States Vice President Miss Kamala Harris. So guys, when you do Venn diagrams, you must know that there is one dignitary that loves Venn diagrams. Oh, I love Venn diagrams. And she will be laughing. I can assure you, if you check YouTube and say Kamala Harris and Venn diagrams, guys, you will see that the Vice President loves Venn diagrams so much. And now you will get to see why she likes them. Okay, so let's see. Now we are doing a presidential topic. Okay, so Venn diagrams, they are a graphical way of basically representing a relationship between two sets. It can be more sets, okay? So remember, it is representing a relationship between two sets. Okay, relationship between two sets. Okay, now, when we talk Venn diagrams, each event, since this is probability, each event is represented by a circle and its outcomes or probabilities. Okay, so what we mean, inside a circle, you can either write outcomes or you can write probabilities of that particular event. Okay, and all other outcomes of your trial will be written outside the circle and inside a rectangle or square. So remember, what I'm trying to say here is that basically for your Venn diagram, you have a square or a rectangle, and inside that square or rectangle, you have circles inside it. So let me show you what they are. So this is your Venn diagram. Okay, this is your Venn diagram. Let's say this is your event. I'm going to label them shortly. This is event A and this is event B. This is your sample space. Okay? Or it can also be like this, where you have them like this. This is event A and this is event B. Or it can also be like this. And by the way, guys, please note, there can be more than two events that you're comparing, okay? Or they can also be like this. Let's call this one event B. Let's call this one event A. Okay? So now what we are saying, we know probability identity. You guys still remember it? Probability of A or B is equal to probability of A plus probability of B minus probability of A and B, right? So with these ones, as you can see, that they have common elements. Two events have common elements, so they are not complementary events and mutually exclusive. But these ones are mutually exclusive events. Okay, these are mutually exclusive events. All right, these are mutually exclusive events. A and B are mutually exclusive. Therefore, this means for this particular diagram, probability of A or B is equal to probability of A plus probability of B. Right? So this is it. This is Venn diagrams. These are Venn diagrams. Okay, these are Venn diagrams. But now I'm going to dwell a bit more into this so I can explain some of the things. Okay, so let's redraw them again. So let's say we have, okay, let me make it a bit bigger. So let's say we have two events, and then this part here is X, this one here is Y, and this one here is Z, and let's call this part here W. Okay, so this is your sample space. Everything inside here is your sample space. Everything inside this rectangle is your sample space. Okay, so X, Y, Z, and W, they are probabilities. So if they say, what is the probability of A only? This means A only means whatever that you're looking for. It is not something that you can also see at B. What will it be? It will be X. In the same way, what is the probability of B only? B only, it means this is only for B. It is not intersecting or shared with A. It'll be Z. And they then ask you, what is the probability of A and B? A and B, common element. What is it? It is that Y. As you can see, it is this portion here. It is this portion here. Can you see it? It is this portion here, which is Y. Okay. Then they then ask you, what is the probability of A or B? What will you say? You guys still remember, with this one, I can show you in two ways. It'll be, you don't waste your time. It'll be, remember, with a union, you will say contains elements that are in at least one of the two sets. So it'll be X plus Y plus Z, isn't it? Oh yeah. Or alternatively, or we can say this, probability of A or B is equal to, you know the identity, probability of A plus probability of B minus probability of A and B. So what is probability of A? We said it is, hold on guys, be careful. What is probability of A? Here you need to be careful. Okay, you need to be careful, guys. Very, very careful. So it will be X plus Y. Be careful. This is probability of A. This means when we say probability of A, including all the elements, I'm going to address this later as well. Now, what is probability of B? It is Y and Z. What is probability of A and B? It is Y. So what is this? As you can see, you have two Y's, but then you have minus Y. Again, this becomes X plus Y plus Z. Alright, remember, when you collect like terms, alright, this is 2Y minus Y, obviously it becomes Y, and it's exactly this. Okay, now, what is probability of A? Probability of A will be all elements inside the A circle. It is X plus Y. Guys, please note, the values given here are probabilities and not necessarily, what is this? And not necessarily the elements themselves. Okay, they are not the elements themselves or the outcomes themselves. They are probabilities. Okay, let me say they are probabilities and not the outcomes. Okay, cool. Now, probability of B, what is it? Probability of B is Y. Okay, it's Y plus Z. That means when I say of B, that means I'm looking at the circle of B. Now, I'm going to say probability of, when I say probability of not, I can either say probability of neither A nor B. It is the same thing. English is the same. Neither A nor B, or not A or B. When I say not A or B, that means, that means I am saying, what am I saying? I'm saying when you are not A or B. What is A or B? A or B is X plus Y plus Z. But what else is not A plus, is not X plus Y plus Z? It is W. So it is simply W. Alright? So what is W? W is basically the total probability, alright, minus these probabilities, X, probability of A or what? Probability of A or B. Okay, maybe I can leave it here. It is this. So this is your Venn diagrams. This is how you will be looking at your Venn diagram. Okay, so now you're going to look at an example now. Remember, we have been doing our examples. We've been looking at the case of Anati and Tiamo. Alright? So now let's look at it. Worked examples. So we're looking at Anati and Tiamo. From Anati and Tiamo, from Anati, we called him A, and Tiamo, we call him or her B. Alright? They were playing a game of 20. Right? Now, if you recall, our sample space was 1, 2, 3, 4, and so on until, let's say, 18, 19, 20. You guys remember? And Anati had chosen factors of 20, which are 1, 2, 4, 5, 10, and 20. Tiamo had chosen factors of 5. Sorry, was it factors? No, it was multiples of 5. It was 5, 10, 15, 20. Right? So now I'm going to say, represent this information on a Venn diagram. Question 1. Represent this information on a Venn diagram. Right? Represent this information on a Venn diagram. Okay? On a Venn diagram. Remember, Venn is someone's name. On a Venn diagram. And then we have already calculated probabilities in the past videos. Now I'm going to say, determine the probability of A only. And 3, determine the probability of B only. Okay? Now, last question, determine the probability of neither A nor B. Okay? Oh, or did I say, okay, because I didn't write the word determine, I will say equal, equal, equal. Okay, equal. Now, let's get our solution. Let's get our solution. Ooh. Let's look at it. Sample space. So we have Anati, Siam. Anati, you chose 1, 2, 4, and if I recall, 5, 10, and 20 are shared. 5, 10, and 20 are shared. So, but 4 will not be Tiamo. You have 15. Alright? Now, hold on, guys. You are not done. There are other elements that are not here, which are outcomes 3, 6, 7, 8, 9, 11, 12, 13, 14, 16, 17, 18, 19. Okay? It's all these guys. Alright? It's all these guys. Can you see that? Now, this is your Venn diagram. Okay? This is your Venn diagram. Do you see that? All the elements that are not our events. Remember, our events is the set of outcomes that we are interested in. They will be outside the circles and inside the square or the rectangle. Right? And this is what we had said. So, now let's answer the question. Represent this information on a Venn diagram. We are done. Now we have our marks. Perhaps 4 marks. Ooh, nice. Now, what is P only? So P only is equal to, remember, now you use the formula, N of A only over sample space. What is it? Let's see. A only. How many elements are A only? 1, 2, 3. Right? Can you see that? 1, 2, 3 are A only, meaning they are not shared with B. It's A only. So let's go. It's 3 over 20. Now B only. Number of B only over sample space. It must be 1. It is 15. Can you see that? So it is 1 element. So it's 1 element. So since it's 1 element, you're going to say it's 1 over 20. Okay, it's 1 over 20. Remember, guys, this Venn diagram is a Venn diagram that contains the elements and not the probabilities. Remember, your Venn diagram can contain probabilities and it can contain elements or outcomes. Okay, let's say elements. Okay, perfect. Now, we're done. Now, what is the probability of not A or B? Ooh, so with this particular question, I'm going to change the color because I've been using red. So okay, let me use blue. With this particular, we need to find, remember guys, not A or not B. What you can do, you can say, oh, maybe save yourself time. You will say number of not A or B all over sample space. Ask yourself, what is A or B? A or B will be 1, 2, 3, 4, 5, 6, 7. If it's 7 and the total is 20, what does it mean? It means you have 20 minus 7 over 20. What is this? This is 13 over 20. Right? This is 13 over 20. So this is how we interpret this Venn diagram. Okay. This is how we interpret this Venn diagram. Remember, you could have also done it in another way, or let me say method 2. Method 2, you could have said, what is probability of A or B? It was going to say number of elements of A or B all over sample space. And what are they? 1, 2, 3, 4, 5, 6, 7. Remember, or, which is intersection, what does it do? It represents at least, it's a set that has at least one of the elements that is in both sets. Okay, at least one of them. So in other words, it means when you talk of a union, it'll include all sets available, but do not repeat them. One that is and one that is available on both of them must be written once. So that means 1, 2, 4, and then 5, 10, and 20 are available to both events. So you must write it once. Hence, I will count them once. It will be 1, 2, 4, 1, 2, 3, 4, 5, 6, 7. Okay. Now we have probability of A or B. What do we do? It's a complement. So what do we say? We say probability of not A or B plus probability of A or B will be 1, isn't it? But in this case, it is not 1. It is 1 because it's probability. It is 1. So probability, what is it now? Probability of not A or B plus what is probability of A or B? It's 7 over 20 equals 1. Then you have your calculator. Probability of not A or B is equal to 1 minus 7 over 20. What is this? This therefore means probability of not A or B is equal to 13 over 20. Okay, is equal to 13 over 20. Guys, you can also find the number of outcomes if you don't have, you can also find the number of outcomes if you don't want to use probabilities, but depending on what's given in your question. But it's okay, we will look at that later. Okay, so this is it. As you can see, it's what we found here. It's 13 over 20. Right, so you guys now know why Vice President Kamala Harris loves Venn diagrams. And the main reason, a simple one, is because it is a way of representing a relationship between two sets. Remember, not only two, it can be more sets. Okay, so with a Venn diagram, it's easy to represent two sets. This is why with a Venn diagram, you will know if they are mutually exclusive. If they are mutually exclusive, you will draw them like this. And you can also know if, basically, you, who is A, basically everybody who is in B is included in you A. Okay, everybody who loves B loves you A. Okay, but not everybody who loves A loves B. Oh, does it make sense? No. Everybody who loves B loves A. Okay, everybody who loves B loves A. Now here, everybody who loves, there are those who love A only and not B. And there are those who love both, and there are those who love B and never love both. And there are those who, hey, I do not like you, I do not like. And this is where they say this service is for, since Vice President Kamala Harris is an administrator, political administrator will say, oh guys, this is for Americans only. Or no guys, this must be shared with other people. Oh guys, whatever that is American is of the world. Okay, oh guys, this is American only. So everybody else, please, this is not yours. It's for Americans only. Okay, this is why she loves Venn diagram. I hope this example or this definition that I'm giving you is not really pressing people too hard. But yeah, this is the beauty of Venn diagrams. Okay, so yes, guys, this is it. This is how we do Venn diagrams. You will see more videos when we do perhaps past papers and other questions that we might be adding. But this sums all that you need for your grade 10 probability. So with that being said, it's a wrap. But hold on. If you would like to get in touch with us, visit our website www.ramtasolutions.co.za. At the top of our website, you will see all these icons. Click on any of these three, it will open your favorite social media platform and you can follow us there. Also click on this one here. For sure, this is where you are watching us. YouTube, you can subscribe, okay? You can like and you can also share this video. All right. And if you would like to get a tutor, we can help you with all your topics, mathematics and physical sciences, or you can have a monthly program with us. We will assist you. You can send us your details on WhatsApp. Please indicate what exactly you're looking for so we can really create a program that works for you, that is tailor-made for you. You can do the same on our using email. You can email us as well. Okay. So with that being said, guys, it's a wrap and